Yeah, so that was the expression. So this is the expression which we have reached upon. We will try to make this simplified by introducing a function. I can write this as equal to 1 by n factorial m by 2 pi beta h cut squared. So basically we have to do the integral, right? So which we have to do here, and so there's a scheme suggested by Part5 in his book for that. You can always go through that. So after that we introduce a simplifying function, and we can write the expression as follows: raised to 3n by 2 sum over p delta p So that is how, where f of z is equal to exponential minus m by 2 beta h cut squared into z squared. Okay, so that is it. Right now, even for this expression we can simplify that with the help of by introducing the parameter which we already know, which we call as the de Broglie wavelength. What was it? H by 2 pi m kt raised to half, and equivalently that can be written as h cut into 2 pi beta divided by m raised to half. You can do it, try to do it yourself. You'll find that this expression and this expression are same. If I do something like this, I can substitute this part of the equation over this one, and then I can ultimately write this as r1 up to rn e raised to minus beta h r1 prime up to rn prime is equal to 1 by n factorial lambda raised to 3n, where lambda is the de Broglie wavelength, sum over p delta p f of p1 minus 1 prime. So I will just write it in, I go back to the original notation we were having, f of p r1 minus r1 prime up to f of p rn minus rn prime, sorry, right, where f of r is equal to exponential minus pi r squared by lambda squared. The same thing over here. So therefore, so that is my numerator which I had to find out. Now going to the denominator, while I am trying to calculate the r rho r dash, the denominator was the partition function qn beta. So qn vt is equal to trace of e raised to minus beta h, which I can always write it as integral r e raised to minus beta h r prime dq bar. We know that. So this means that here in this context it will get converted as integral bracket r1 up to rn e raised to minus beta h r1 prime up to rn prime bracket d cube rn. So which can be simplified with the equations given in the appendix by Patria. I can write it as is equal to, what I do is that I have already calculated this in the quantity within the integral over here, this expression, right? So this I will substitute over here, do the integral, and then what will I get? I should be getting 1 by n factorial v by lambda cube by n factorial v by lambda cube raised to n. So now what would I do? I will, so this is my numerator, this is my denominator. So if I, in order to find the density matrix expression, I will, the numerator by denominator. So therefore I can write r1 up to rn rho r1 prime up to rn prime is equal to 1 by v raised to n, right? Numerator divided by denominator, 1 by v raised to n, sum over p delta p f of p r1 minus r1 prime up to f of p rn minus rn prime. Right. So basically, so this is the expression. Basically, this expression tells me the probability of exchange interaction between particles in a box of multiple free particles. So this is the expression which we needed to find out. Okay.